Hello and welcome to today's tutorials. Today we're going to talk on the elimination process using the matrix. In the last tutorial we have seen an example of 2 cross 2 matrix where we have eliminated the rows using the linear equations and with the elimination method or Gaussian elimination method. So before going into the matrix method, we will see the 3 cross 3 elimination using the row method or equation method. So then we'll go for the matrix method. So let's hit back to the screen and let's see that. Okay, so now let's take an example of a 3 cross 3 matrix. So the 3 cross 3 matrix here is, let me share the screen. Yes. You all can see the screen, the white screen. Yes. Okay. So now we'll take an example of 3 cross 3 matrix here. So let's take this as 2x plus 4y plus 4y minus 2z equals 2 and 4x plus 9y minus 3z equal to 8 and minus 2x minus 3y plus 7z equal to 10. Now we want to find out the values of x, y and z, these unknown values in these three equations. Now there are three equations and three unknowns, so we have to find the value. So normally we used to do by just multiplying any rows with any number and then subtracting, but we have followed one method in the last tutorial or in the last class, that is the elimination process. So that we call it as a Gaussian elimination. So we apply that Gaussian elimination process for this 3 cross 3 matrix and we'll see what we get. So as usual, this first thing here, the first component or the coefficient of x is nothing but our first pivot, and the first condition is that this first value cannot be 0. So now it is not a 0, so it means we can proceed. So now first we have to eliminate this 4x. So how do we eliminate this? It's very simple. Now what we'll do is that we will multiply the first row with 2 and subtract this with the second row. So and then we will write back our first row as it is. So let us write back the first row, that is 2x plus 4y. Otherwise I'll do one thing. Just for subtraction method, I'll write down the second row first here. So 4x plus 9y minus 3z equal to 8. So now I will multiply, so I need to get 4, so it means our multiplier is 2. So 2 into the first row is nothing but it is 4x plus 4 to the 8y minus 4 2 to the 4, so I'll get 4z equals, I'll get 4. So now let us subtract this, multiply the first equation, the 2 times the equation 1, subtract the 2 times, if you want to say in definition, so subtract the 2 times the equation 1 from equation 2. So that is what it means. So now if you subtract this, what do we get? So x terms will get cancel up. So now here I'll get y, so and here I'll get plus z equal to 4. So now let us write all these here on the left side. So now we have 2x. So now it means we got in this form. So it is 2x plus 4y minus 2z equal to 2. And what is the new thing, new equation we got? So we got the new equation as y plus z equal to 4. So now we have eliminated this first coefficient here in the second row. So now what we will do is that we will continue and now we will eliminate this one. So to eliminate this, again we will follow the same method. We will multiply some multiplier to the equation 1 so that I can subtract this. So what I will do is that I'll multiply this first row by minus 1 and I'll subtract with equation 3. So by doing that, what we will get is that, so let's see here. So I'll write the third row here. So 2x. So 2x minus 3y plus 7z equal to 10. Now I'll multiply by minus 1 to the first row. So I'll get minus 2x, then minus 4y, then plus 2z equals minus 2. Now I am going to subtract this. No, so I'm sorry, this I have to multiply this with plus 1 itself, not minus 1. It's my mistake. So just take this eraser. So it's minus and that's plus. Yeah, now let us subtract this. So what do we get here is that I'll just shift this up. There's no place for me here. So now what happens? This will get cancelled. Oh shit. Oh shit. Sorry. I'm going to rewrite this completely. Mistake from my side. I'll delete this one as well. So let me rewrite here. So let me write minus 2x minus 3y plus 7z equal to 10. Now let us multiply by minus 1 with minus 1 to equation 1. So I'll get minus 4. It was correct actually, in fact it was right. So this will become plus 2z equal to minus 2y. Now if we subtract this, so what happens here is that this is the method rather than straight away cancelling up. So this is how we have to do it. Now what happens, this x and x it cancels. Now here I get y, and here this is 7. So 7 minus 2 I'll get here plus 5z. So plus 5z equal to, now here 10 minus 10 plus 2 I'll get it 12. So I got the next method here as y plus 5z equal to 12. Now we are in the second step. So this is the first step was to eliminate the x from here, and the second step was to eliminate x from here. Now still it is not in a the upper triangular form. We have to bring it in upper triangular form. So to bring this in upper triangular form, so what we have to do is that now I'll take these two equations here, and I'm going to eliminate the y from this third equation by taking equation 2. So what I'll do is that, so here the multiplier factor is 1. So I'll multiply 1 to equation 2 and subtract from the new equation 3. In fact, I'll call this as new equation 3. So let us see what do we get here. So I'll just come down here. Now I'll write the new equation 3, that is y plus 5z equal to 12. And now I'll multiply with 1 itself plus 1, so that I'll get back the same thing, so that I can subtract it. Now let us subtract this equations. So then I cancel out y, and here I'll get this as 4z equal to, now what I get here is that I'll get my 8. Perfect. So now let us write the new, once again the final equation which I get from this is that, so I'll put the line here and write. So from this second method we get back our one more new set of equations. So if you look into new set of equations, the first row will written as it is, so that is nothing but my 2x plus 4y, let me write neatly, so the 4y minus 2z equal to 2. Then my second equation will remain as it is after the step 1. So this is y plus z equal to 4. Now if we will write this new form here in this equation, then I'll get here my 4z equal to 8. So this is our forward elimination process, and now I got these equation in a triangular form in this way So now you say that it is in a proper triangular form. Now with the back substitution method, I can find my x, y, and z. Now back substitution method is that, now what is the value of z from this last equation? So I'll get z is equal to 2, and likewise this z is substituted in equation in this second equation here in the new form. So I'll find y. So I'll get what is the y I'll get here? So just substitute this 2 here. When you subtract this, I think we will get y as 2, and then what is the x we will get? Then I think x will get this as minus 1. So hope it's correct. I'm not simplifying, I'll leave it to you. So yeah, right. So hope this example is clear. So now the new values or sets of these known values are x, y, z for a triangular form. Sorry, for 3 cross 3 matrix, it is found in this way. So likewise, this same process is applicable for n cross n matrix as well. So now if we going to write this, so now we know our these coefficients of x, y, and z. So let me save this here, and then I'll come back to the new page. So let's take a new page, and let us write this in our the form, in a normal form, how we used to write, that is ax equal to b form. So if you write this a 3 cross 3 matrix in a vector form, so then the ax can be written as, it means now our ax, or the value of x is nothing but minus 1. It means the first column of a, the coefficient is multiplied by minus 1 times. So now the coefficients are 2, 4, and minus 2. Then plus, it is the value of y is 2, and it means the 2 is multiplied with the second column of this A matrix. Not matrix, the A coefficients, because still we are not started with matrix. So then one more 2 here, so that means this is z value, so it means we are multiplying with the third column of the coefficients, and that is equal to now the b. So b is nothing but our right hand side of the vector, that is 2, 8, and 10. So this is equal to b. Okay. Sorry. Now we will write a few points here. So during elimination, what happens here? So a few conditions we will write here. The whole idea for column by column to bring in from A to U when elimination is succeed. So for that means, so column 1 is use the first equation to create zeros below the first pivot. So we are writing the algorithm for the previous method that we have applied. The second is, second column 2, we get use the new equations, use the new equation 2 to create zeros below the second pivot. Then third column, in column 3 to n, keep going to find all n pivots and the triangular U. So that is what it means. So now likewise, if we write here for n cross n, then it looks like for n cross n matrix, then it is x, 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 then what happens? This is 0, then we eliminate this, then we'll get this x, x, then we eliminate these two terms here and we have some coefficients of this x. So likewise this process continues, okay, for n cross n matrix. So this is the method to find this. So now let us go for the next topic. Any queries so far? Okay, so then we'll go ahead with our next topic. Now we have seen this elimination process using this equation method. Now we will try to say this elimination process with the help of matrix. Now we will try to represent all these in a form of matrix and we will see that. So let me give the heading as, save this page here. Elimination using matrices. We'll take the same 3x3 matrix, similar kind of 3x3 matrix, and then we will see this. What are these terms here? So let us take a matrix that is 2x1 plus 4x2 minus 2x3 equal to 8, sorry, equal to 2, then 4x1 plus 9x2 minus 3x3 equal to 8, then minus 2x1 minus 3x2 plus 7x3 equals 10. So just a minute, hold on, I'm getting a call. So we have taken a 3x3 matrix here. So now we will try to represent this in a matrix form in the same way like how we used to call this, that is nothing but in a form of AX equal to B. So if we bring it in a matrix form, then all these coefficients will put it in A. So now our matrix will be, a first matrix will be a 3x3 matrix. So that is 2, 4, minus 2. So all the coefficients we are putting in here. So 4, 9, minus 3, minus 2, then minus 3 and 7. And here the unknowns, we'll write it in a vector form. So that is my x1, x2 and x3. This is equal to the b, the right hand side, which should be equal to, so now that is 2, 8, 10. So this is how we used to represent this in a matrix form. So generally, so this is our 3x3 matrix and we have 3 unknowns. So likewise, generally this is represented the coefficients for n equations. There will be n cross n matrix and there will be a vector of n dimension space. And remember this, an n dimension space, see this is represented by Rn, but here since it is a 3x3, so we'll write this as R power 3. So this is a very important term. This 3 represents the dimensions. So it means now we are talking in terms of 3-dimensional space. If it is R square, so it means we are talking in terms of 2-dimensional space. If it is R9, it means we are talking in terms of 9-dimensional space. So that is what it means. So now R power 3, so where we have the x as 3 unknowns, that is x1, x2, x3. So we are not going to solve it here. We'll just quickly look into the relations here. So this is my x1, x2 and x3. You can find out these values of unknowns later, but now I'll give these values here. So these values after solving we will get here as -1, 2 and 2, right? So now if you represent this in terms of a column, so this column form can be represented in matrix as AX in the same way how we represented this before, that is minus 1, that is nothing but the value of X with the first column of this A, that is coefficient, that is 2, 4, minus 2, plus, now this is 2 into, it is 4, the second column of this matrix, this coefficient A, then plus 2 into minus 2, minus 3 and 7, that is the third column, which is equal to B. So here AX is a combination of columns of A. So generally we used to write this as I'll write this as AX is equal to X1 times column 1 plus X2 times the column 2 and so on, dash dash, it will continue, plus Xn times column n. So this is how we will read it, components. And now if you say this, so if we take one particular component, the ith component is a dot product with row I of A. So now if we look into this, so how do we say this? Now if we take this one particular row, so it means that is 2 into x1 plus 4 into x2 minus 2 into x3, correct? So we used to write in equation form, that is how we used to write it in that way. We get this equation, so it means it is a sum. So generally it can be written as the ith component so then the ith component of AX is, so we can write this as AI1 into X1 plus AI2 into X2 plus dash dash, and finally we can write this plus AIN into Xn. So this can also be written in a form of a summation, so that is nothing but, we can write this is equal to nothing but a summation of j is in another row, so j is equal to 1 to n aij into xj. This is a very general form of writing this. Okay, so this is about the matrix representation. Now we will look into the elimination process. So previously we have seen how to eliminate. We know the algorithm how to eliminate. For example, if I want to eliminate this, so I have to multiply the first row with 2 and subtract with this equation 2. So I am going to eliminate this. So that is fine. That is a manual method of doing. But as a computer, if you want to program it, so when we represent these coefficients in a matrix, so how to take out that. So that is what we have to see next. So let me save this here. So I will call this as page 66. Okay. So write the new heading. Let's take the new page. So the matrix of one elimination step means we are going to talk about only one elimination step. That is why we have written. So before, so generally we used to write in this way is equal to B. This is our original equation form. So A are the coefficients and X are the unknown values, unknown variables, which is supposed to be equal to B. So this is how we'll write. Now we'll see there's only the B part here. For example, let's take the right hand side. So right hand side, say B, it is 2, 8, 10. I think this will be the same as the previous example. Yes, 2, 8, 10. So now in this 2, 8, 10, let us understand this. So if I want to eliminate, if I want to reduce this by some factor, if I want to divide this by 2, then how should I do within this matrix? So I cannot do that straight away because it is in a matrix form. So I need to bring it, I need to multiply with something so that it will eliminate. So there comes the new kind of a matrix, that is, we call it as an elimination matrix. So elimination matrix comes into existence by the identity matrix. So what is our identity matrix? So identity matrix is nothing but, this is I. If I take a 3 cross 3 matrix, because here the vector is a 3 cross 1, sorry, it is a 1 cross 3, so I'll take this as a 3 cross 3 matrix here. So the identity matrix for 3 cross 3 is that we will get here 0, 1, 0, 0, 1. So this is our identity matrix for 3 cross 3. Now I want to eliminate the second row or second row value by 2, or I want to bring down by 2. So how do we do that? So for example, I want to bring it this like a new form as 2, 4 and 10 by not changing any other values, just I want to change this middle value. So to change this middle value, so what we have to do is that we have to multiply with a modified version of this identity matrix, that is nothing but an elimination matrix. Now since I want to change this second component of this vector, so I have to bring it, so here it is 8 and here I have to bring it to 4. So what happened? So I'm going to multiply this first component by 2 and I'm going to subtract with this second, so I'll get this 4, right? So to get that, what we have to do is that I'm going to modify this identity matrix, that I'll keep it. I'll keep all other components or the coefficient of this matrix as it is, but I'm going to change only that component where I want to a multiplier. So I now in this case the multiplier is -2. So now let us take this and see, multiply with this and see what do we get. So now we are talking about E into B. So when we talk about E into B, we have to be very particular. It cannot be B into E, and B into E will be something else, because in matrix multiplication we have to be very, very particular. Now let us take this as 1, 0, 0. Now this is -2, 1, 0. Now 0, 0, 1. Now let us multiply this 2, 8 and 10. So what do we get here? What is our new matrix or new vector? So this is 2 I'll get. So then here I'll get, let me write a little bigger. I'll just remove this. So this is -2 plus 8. Sorry, it is not -2. It is -2 into 2, so I'll get -4 plus 8. And then here the last row, everything remains same, so I'll get back my 10. So if I rewrite this, so I can write this as 2, 8. I can write this as 8 minus 4 and 10. So I'll get this is nothing but 2, 4 and 10. See, I have eliminated, or I have taken out by 8 to 4. So if we write this in this term here, so this is nothing but 2 is what? This term. So for example, generally if I want to write this as say B, what is this B components? So B component is nothing but B1, this is B2 and this is B3, the first and second and third component. So now if you see here, so 2 remains to be 2, so I got the new vector as the B1. What about the second one? So second one is nothing but here it is B2 minus B1. So that is how you can see B2 minus B1 and B3 remains to be same, B3. So this is how we can multiply an elimination matrix to remove anything. So here, what is our multiplier? So here the multiplier term is this minus 2. So that is what you can see from here. So I have modified my identity matrix with this placing here. So for example, it's very simple. If you want to eliminate the second component here by some factor, so you have to put that here. If you want to do the same thing with the third component, so then based on that we are going to replace here the zeros with that multiplier factor. So that is the funda of this elimination process. Right, now let us try one more example here with a new B. So let us take the new B here and identity matrix, and I'm going to fit in now. Let's take my B as 1, 3 and 9. So this is in a vector form. So I want to bring this component to 5. So what should I do? So now let us look into our identity matrix. So identity matrix is 1, 0, 0. I have to take a 3 cross 3 matrix, then 0, 1, 0, then 0, 0, 1. So now if you see from this, so identity matrix, if it is multiplied by B, I'll get back my B itself. So it means what I need to do is my elimination matrix, I want to place it. Now if I want to subtract, if I multiply some number here, so that I can get, here it's a back method. So now I want here 5, so it means 9 minus 5 is nothing but it is 4. So now I want to subtract it. So what you do is that the multiplier, you place it as a minus 4. So 1, 0, 0. This is 0, 1, 0. So now what you do is that the multiplying factor, you put it as minus 4, and remaining values you keep it as it is, 0 and 1. Now let us multiply this elimination matrix with B. So what do we get here is that 1, 0, 0, 0, 1, 0, and this is minus 4, 0, 1, and let us put our B coefficients here, B vector values here. So then when you solve it, what do we get here? So this is 1 I'll get, so here I'll get 3. Now if you say this, I'll get minus 4, so I will write this as 9 minus 4. So ultimately I'll get this as 1, 3 and 5. The new vector I'll get it. So I have to place this a non-zero value or a multiplier value in a position where I want to remove it. So this is the trick to create this elimination matrix. So elimination matrix has to be generated based on the requirement by substituting the multiplying factor. Hope you all have understood this. Now let us look into a few techniques. Now let us apply this to our entire coefficient, this elimination matrix. Now since we applied only for the right hand side of the vector, now let us apply this elimination matrix to our coefficient matrix, that is A. Let us save this. So I'll write the heading here. So now it is matrix multiplication. It is not just matrix multiplication. We are going to multiply by elimination matrix. Now we have seen from the previous example, let me write like this. So now we had 2x, let me write it properly, 2x plus 4y minus 2, which is right hand side. We are not interested now because we are not going to solve it. We just want this, the left hand side, let it be. I am not interested in the right hand side now. So then 4x plus 9y minus 3, this is z, this is 3z. Now it is minus 2x minus 3y plus 7z. So this is given, which is equal to right hand side is something else. Let us not bother it. Now if you want to represent this in a vector, in a matrix form, so how do we represent? So all the coefficients we used to write like this: 2, 4, minus 2, then minus 2, then it is 4, 9, minus 3, then it is minus 2, minus 3 and 7, which is into a vector that is x, y, z. Okay, so this is nothing but it is a into x. Now we know from the equation method, so how to bring back how to bring this matrix, or how to bring this equation into upper triangular form. So there is nothing but I have to subtract, I have to multiply with this value, so this is my multiplier. Now it means I have to bring it, I have to multiply such that I should get this value, okay, to the first equation, and I'll subtract it. So that is our equation method. So now how do we do this now with the elimination matrix? So to do that with the elimination matrix, as we have discussed just before, that I have to modify my identity matrix here. So my identity matrix is 3 cross 3 now. So it is 0, 1, 0, now it is 0, 0, 1. So this is my identity matrix. Now what we have discussed that, so I have to multiply 2 times, subtract 2 times the equation 1 from equation 2. So it means I have to multiply this first equation by 2. So if you want to multiply this first equation by 2, so then it means that here, since I have to take out this term here, so then what I have to do is that in the identity matrix, I have to replace this term here from 0 to that multiplier. So now that multiplier is nothing but it is minus 2. So now let us, now this has become, it is no more identity matrix, now it has become your elimination matrix. So now let us do E into A and see what do we get. So now this is my elimination matrix 1, 0, 0. So now this is minus 2, 1, 0. So now this is 0, 0, 1 with this my coefficient matrix, that is A, that is 2, 4, minus 2, and this is 4, 9, minus 3, and this is minus 2, minus 3 and 7. So when you multiply this, what do we get here is that when this first value here, when it is 1, so I'll get back my all the first row as it is. So we can just write this as 2, 4 and minus 2. If you want, you can just cross check. So this is 2 with all other values are 0, then 1 into 4 plus all other values are 0, then 1 into minus 2 plus all other values are 0. So I'll get back my first row. Now to get back this second row, all other values should be 0 and this middle value should be 1. But here we have added one new component here, that is minus 2. So now what do we get here is that 2 into 2 minus 2 is minus 4. Now what happens? Minus 4 plus 4. Then what is the next term here? Now this second row entirely it will going to change it, because we have multiplied 2 for the first row of this coefficient matrix. Now it is 4 to the 8, and now it is minus 8 plus 9. Then we have minus 4 minus 3, whereas the third will remain same. The third row will be just as it is, minus 2 minus 3, and then it is 7. So now when you simplify this, you see this is 2, 4 minus 2. Now this has become 0. So now this has become 1, and this has become, is it minus 7? I think something I have missed it. The third row is minus 7. It is minus into minus, it is plus, sorry. So it is plus, so it is plus 1. So now the third is minus 2, minus 3 and 7. So this is how we can obtain in a matrix form, whereas in equation form we know that we multiply this and then we subtract it manually and we'll do it. But in a matrix form, if you want to do it, we have to multiply this the coefficient matrix with the elimination matrix so that we can get this. So if we continue this and we want to get back our triangular form, so what is the next thing that we have to do is that now the next thing is I have to take out this minus 2 in the third row. So to take out this minus 2 from third row, now I have to take this matrix here and I have to multiply with one more elimination matrix. So can you tell me what should be a multiplier value in this new elimination matrix? Let me call this as F. So F is what? So and where you are going to substitute? Tell me. I'll just write the identity matrix and I'll leave it as it is. Now you have to tell me what is the right answer for this. What should be the multiplier for this? Anyone? There are no replies. It's very sad. Okay, fine. So let me continue myself. So here, so this is, I'm not going to touch the row 1 and row 2. I'll give it as it is. So here what I will do is that since I have to take out this first component, I have to get this, when I multiply this first pivot with some multiplier, I should get this as equals to this so that it can get subtracted. So I'll just keep it as 1 itself. So now this is my new elimination matrix. Now F is equal to this. Now if you multiply this with this, what do we get? So let me bring this here. So I'll shift this entire thing so that I can avoid writing this terms. So now if I multiply this, what do I get? So let's see, what do we get here? So this is equal to, I'll get back my first row as it is. There is no change in the first row, so it is 2, 4, minus 2. So now the second row, I will multiply this. I'll get back my same terms here, 1 because all other values are 0 in that. So now if you see here, so what do I get here is that, so that is 2 minus 2. Then here what do I get is that 4 minus 3, then minus 2 plus 7. So when we simplify this, what do we get here is that, so I'll get my new matrix as 2, 4, minus 2, then 0, 1, 1, and here I get the 0, and here I'll get this as 1, and here this is 7, so I'll get this as 5. So this is my new matrix. So now the next term is that still this term is not 0 here. I have to bring this to 0. So what should I do? So I have to multiply again this new term with one more elimination matrix. So one more elimination matrix I'll leave you to find out so that I can take back this term. So I should use my second row. Let me give you the hint and multiply with some multiplier that is 1. So then you simplify it and subtract this equation 3 from equation 1 and you will get back your final term, that is the final ultimate upper triangle form. So this is how we'll do it, and here we will discuss a few more topics with respect to the multiplication of this matrix here. Let me save this page. Whereas so that is the multiplication property will satisfy the associative law, but it does not satisfy the commutative law. So this has to be very, very clear. So it means the commutative law is that I'll come to that. First let me write this here. So associative law is true, which is nothing but A of BC is equal to AB into C, whereas the commutative law is false. It means A into B is not equal to B into A. So it means that let's take an example. For example, we have the three values of 4, 5, 3, 4, 5. So if you multiply 3 into 4 and then multiply with 6, I'll get it as 60, which is same as 3 into 4 into 5. It means first I multiply 5 with 4 and then multiply that result with 3. It's again result in 60. But whereas here in matrix 3 into 4 is, it is true that 3 into 4 is also equal to 4 into 3 in a general mathematics, but in case of matrix it is not same, because A into E will give us different results, whereas E into A will give the different results. So just take any of the example and work it out so that you will understand. So then we have to be very specific while writing here. So it means in the matrix form, so when we write this as E into B with the once a matrix, so it means this is E times it is B1, then E times it is B2, then E times it's B3 columns. Okay, so column at a time. So we are talking in terms of column here, so it is a column at a time. Now let us take an example here and see that to make this better understand. So I'll take back my A matrix here. So let us write the A matrix here. So I'll write my A matrix, that is 2, 4, minus 2, and this is 4, 9, and minus 3, and this is minus 2, minus 3, and 7. So this is my A matrix. So now what we'll do is that we will take our elimination matrix and multiply. I'll just take one of these columns and multiply with our E matrix. So let us see this E into A, our elimination matrix, that is nothing but 1, 0, 0. This is minus 2, 1, 0, and this is 0, 0, 1. And if I take the third column here, so minus 2, minus 3, and 7. So what do I get here is that I'll get back the new form of the same column of A. So this is equal to minus 2, 1, and 7. So this is new column. So if you write this statement wise, so it means it is E of column J of A equals, it is a column J of E into A. So this is how we'll read it. Okay, so hope you have understood this topic, and in the next lecture we're going to talk about the usage of permutations in this matrix method. Thank you.